Hi, I'm Kendall G. I work with Crop Intelligence.
And I'm Curtis Russell, and I'm with Taurus.
We're here today. Taurus and Crop Intelligence have been working for the last couple of years with a bit of a strategic partnership. We share a lot of customers in common, and so we've made an effort to understand each other's products and how they can work together to help our customers grow a few more bushels or increase their profitability. So today we're going to walk through some of those synergies and how you can make the most of soil moisture data on your farm.
So what is Taurus? So Taurus is an agriculture marketing company that represents other companies that are innovative and looking to push the limits of agriculture. So products like Crystal Green are marketed by Ostera, Active Inoculant, which is sold by Premier Tech out of Quebec, Active Agri, which is now based in Saskatoon, and Sulphur Plus, which is based out of Kentucky and is a synthetic gypsum. So what we're always trying to do is look at what's new, what fits agriculture, and what provides value to our customers across Western Canada, and then help them to ultimately be successful and give them the advice to fit their programs and their farms.
Crop Intelligence is an app that was built in Regina, Saskatchewan. And so it models water-driven yield potential based on in-field soil moisture data and real-time rainfall information from your field. It also uses 30-year historical rainfall averages to help not so much predict, but estimate what could happen in the future. And we talk a lot about incremental improvements, and there's decisions to be made all along the growing season, from the planning process in the winter through the first seeding decisions and herbicide, through our top dress timing and into fungicides. There's incremental improvements to be had all along the way. And when you know what's happening below the soil surface and what's there for soil moisture and rooting activity, there's a lot of clarity that can be had. So,
yeah, we hear a lot that logistics trumps agronomy, but what's interesting about the Crop Intelligence tool is that the information that a grower can pull from it allows them more time, more information, less, it rained today, I'm going to go top dress, and then how am I going to figure this out? There's just more planning and more time for them to consult people like us and other industry experts. Maybe that's their local retail or professional agrologist. It just takes a little bit of the panic out of farming.
Why does soil moisture matter? So farming in dryland farming and in Western Canada in particular, we generally farm in a rainfall deficit. Except for some years when we have an upside and there's more yield opportunity. So we started with soil moisture monitoring in dryland in 2014. And at that time, we weren't really sure what to do with the information in dryland. If it doesn't rain, there's not really anything that you can do about it. But there is something pretty powerful in understanding where in your soil profile your soil moisture is, where your roots are active, and then using that information to help make some really key decisions throughout the growing season. And so that's kind of the hope behind Crop Intelligence as a product. We're not setting out to predict yields as much as we would like to understand what is your overall water-driven yield potential. And if you know that throughout the growing season, how can that help you optimize decisions? So we tend to leave our soil moisture probes in the ground late into the growing season through harvest, and we get a fall soil moisture reading at the end of October. It says you've got 4.5 inches of crop available water in the soil. We know on a 30-year average, if you're farming near Regina, Saskatchewan, that you're going to get about 4 inches of winter precipitation on average, and anywhere between 7.5 to 8.5 inches of in-season precipitation for next year. So we have that information, and with that, based on normal farming practices, you've got potential for 65 bushels of canola, depending on how much in-season precip you get. So if you're working with a farm customer and you have that information, how does that change the conversations and the decisions that you're making?
The more information you have to help a grower formulate a plan, it just gives you the opportunity to be more confident in what you're doing. And I think a lot of times people believe that some of these products that we sell are there to substitute their current plan. And in almost all cases, it's the exact opposite. It's there to use in conjunction and to be used the right way.
Yeah.
And I think sometimes what I really love the fall reading. To me, that was one of the best additions, because the decisions in agriculture today, the ones that really matter and make the biggest differences, are made in the wintertime.
Yeah, absolutely. So if we're in a canola field and we know this customer has pretty industry standard, Saskatchewan standard phosphorus levels. You know, he's got some low soil test phos. He wants to grow some big bushels. He knows that he has the water to do it if the upside is there. Is there any kind of planning strategy that you guys, or that has worked in the past for you?
You know, the reason I came to Taurus was because I believe that phosphorus is, in some cases, more limiting than water.
Yeah.
I think the planning for that starts in the fall, and some growers are making their phosphorus decisions right now in July. So the sooner the better, depending on the farm. And I would say that it isn't about hitting it with a foliar. It's about starting with a very solid phosphorus program. Canola, of course, is harder because it's a lot of the fertilizers we have today have heavy salt load, and it is hard to just turn it up to even the levels that most growers want to do. Yeah. And like a product like Crystal Green, why growers are migrating to it is because it allows them to put as much as they want with the seed safely. You know, there's always limits, but in general, it's that simple. And in some cases, they might have much higher parts per million than they think. So, you know, healthy soil tests, have a look at them. Don't just assume you don't have a good program. Yeah. And just make a plan. So what I love about the crop intelligence probes is we sometimes see visual differences on top. You know, we'll see canola flowering at a different time,
right,
in high or low phosphorus situations, or what the grower chose to fertilize with. But what I love about crop intelligence is we can actually see under the ground and see that we're driving roots.
Yeah. With
real data, not a 5-gallon pail and a bucket of water. And it's something we can review with the customer after the season when they're not running around trying to get everything sprayed. Yeah. I'm a bit of a data geek, and I love the fact that I can have a real conversation based on real information. Farming's full of hypotheticals already, and it's already hard enough.
So speaking to like where in the rooting profile or where in the soil profile your roots are, the soil moisture probes that Crop Intelligence utilizes are capacitant soil moisture sensors. So we get individual sensor readings at various depths throughout the soil profile. And so you get a measurement at each, and you can watch as the crop starts to use water at each of those depths. As it uses water, your total crop available water starts to decrease, and the percent soil moisture at each depth goes down. So you can watch as that crop's roots hit 10, 20, 30, and 50 centimeters. And we watch as our canola and our wheat crops use quite a bit of water from 70 centimeter, and in a lot of cases they're using significant amounts of water from 100 centimeters. So that's something that is interesting to be able to watch and understand what that crop's capacity to tolerate a little bit of drought stress is. You know, how are we going to fare through a dry period through flowering, depending on how much water is in the ground.
Yeah, when I was a young rep, I remember standing in a field with in a canola field, and someone said to me, if the canola is this high, you know, you can expect the roots to be that deep in the ground.
Interesting.
And that was profound to me. It's not that simple. You know that.
Yeah.
We know that now.
Yeah.
But as a young agrologist, I just didn't think of it as that deep. I didn't understand the difference of the water holding capacity of certain types of soil and how different they are.
Yeah.
It's
And how flexible that rooting depth is too, right? A drought stressed crop is going to drive down searching
Yep.
for water, and it's going to have a higher root mass ratio to its above ground biomass. So.
yeah. So in the last 15 years, we've been through, I would say, some of the driest conditions in the last little while here. But what we learned, especially last year, that it wasn't as bad as we felt,
Yeah.
including myself.
Yeah.
And then, of course, I've been through the real wet years where, acres weren't even seeded. It was so wet, and where you really saw that shallow rooting, and it just didn't drive down. And we just couldn't get to those yields that, even though we had lots of rain,
Just wasn't there.
we just couldn't do it. So I think when I kind of got interested in crop intelligence, it was long before I came to Taurus. What really made it interesting to me was to try and understand throughout the season whether we've had too much, too little. And in a lot of cases, I had growers say to me when I was selling fungicide, what's this going to yield? and that's, for the last 5 years of walking fields and staging canola, I wasn't staging canola.
Yeah.
I was helping that grower to help understand what the yield potential was at that snapshot in time.
Right.
Now I just show them the phone. and I have the confidence to say that it's here as long as you've done this, and this, and have a little more in-depth conversation. Mother Nature has given us this. What have you done, and can you get there?
Exactly. In terms of understanding what a water-driven yield potential number actually means. And so we talk about it in terms of your overall maximum potential of a crop, based on the genetics of the crop and the environmental conditions where you grow, like the actual solar radiation, the amount of carbon dioxide in that, how that plays into what this crop can actually do. And then the next set is what's possible with the water on the field. And then the third level is what we actually pull off the field. And your actual yields reflect the combination of everything. So the genetic potential of the crop, the water that was there, and then all the things that you did throughout the growing season. So that's, the nutrient limitations that it may have seen throughout the growing season, some setbacks from weeds or disease, or, reduced stand establishment. Those types of things are not factored directly into the water-driven yield potential numbers. So if you're heading into seeding, you had last year's fall soil moisture, things are looking pretty positive. Are there any things that you can do pre-seed in terms of driving roots or building a stronger plant?
Driving roots is something that we know will have a lasting effect throughout the life of the plant. It's not about, a short-term blip.
Yeah.
It's about getting that plant up and going. And when we were reviewing data from AIM at South Country there, we just stumbled into it last year that we actually have a moisture probe in standard practice, so not untreated, so standard practice, something that, vast majority of growers in Western Canada do.
Yeah.
And then a treated with a number of Taurus products. So what we would recommend if we were sitting at a kitchen table, as long as it made sense agronomically.
Not the kitchen sink, but almost.
That's right. And at the right rates.
Yeah.
And the goal is to see if we see anything visually, of course, above ground. What Crop Intelligence did, and what surprised myself, was that we did see drawing at different depths quicker.
Yeah.
So I think last year it was like 4 or 5 days sooner. And then this year, we saw a slightly taller, minute, but it was slightly different, more robust plant.
Yeah.
But then again, below ground, we saw that same 5 days.
Yeah.
And I think...
And it was the difference between the roots started pulling about the same day. On the treatment, they were pulling at 30 centimeters 5 days sooner than the check.
Yeah. And we're not talking about a half mile away. This is from, well, less than me to that moisture probe.
Yeah.
So very similar soil. It's something that to me is very interesting.
Yeah, and 1 year is one thing, and as you start to see these results, that's pretty exciting stuff. So.
And what's really interesting when you look at a crop intelligence probe with a herbicide application, and you can see those roots still going.
Yeah.
There is something about that that is very, it's very, very, a lot of satisfaction.
Yeah.
Because you know that plant hasn't shut down. And products like Build, the idea of that is to keep that plant pushing roots and keep growing. And I think that's likely where this 5-day window comes in. We're learning together on this, so we're going to hopefully spend more time trying to dial that in. And that's something that I'm very interested in, is to quantify this herbicide stress, which products of ours and which herbicides we see the greatest value with some of these products.
So in 2019, we had some stations in the Ag in Motion plots, in Taurus's Ag in Motion plots in canola, wheat, and peas. So I thought I'd just run through some of the data and what that looked like from last year. So to each of the canola, and each of these tiles reads soil moisture, crop available water, water-driven yield potential, the total accumulated rain for 2019, and the percent average. So we're sitting right around normal. Last year they had about 200 mils to give them 96% of average rain. We want to just go in and look at the wheat site here. So on near average rain, and just with the timing of the rain, a lot of the rain came later in the season where it was not as necessarily efficient at putting that rain to bushels. We sat about 9 bushels off of their yield goal in terms of what was there for water. So when we come into the water-driven yield, I like to start at the beginning of the season to kind of get a feel for what was happening on the growing season. So the sites were seeded and the stations were installed in the first week of June. And right off the bat, they started with some decent soil moisture, so about 6.5 inches of crop available water, and a water-driven yield potential of about neutral. So if they got average rain, they were on track to meet their yield goal. As we go through the season, this week is a really critical week here. So the 17th to the 25th, I think some of this was irrigation as well. I'm not 100% sure, but in that kind of time period, those timely rains really boosted this crop into a yield positive scenario at about 170% of average rainfall. And that's really key to have that water in place prior to peak crop use. As that crop moves from vegetative stage into the reproductive stages, water use really ramps up. And so now we're sitting at about 7.5 inches of crop available water, and we've also had some root use, some crop use. So this rainy period here, I believe some of that's irrigation as well. And then we had a pretty extended dry period where things would have started to go backwards in terms of the overall water-driven yield potential, and finished out the season with a slightly negative water-driven yield potential and about 4 inches of crop available water in the soil. So from that peak time of 7.5, there's 3.5 inches total that is a change in the soil moisture profile. So then I always like to look at soil moisture sensor data. So we have capacitance sensors, and we have, they're measuring volumetric soil water content at each of the depths, 10, 20, 30, 50, 70, and 100 centimeters. And so each of those independent readings gives us an idea of change day over day at that sensor. And from that, we can start to identify, consistent change day over day, which helps us to know that there are roots actively using water at that depth. So it's kind of interesting to be able to watch a crop start to use water, use it really heavily through those vegetative periods, and move through the profile and access water at different depths. So again, we started the year with, near field capacity kind of range, maybe a little drier, but certainly soil moisture throughout the profile. Each of those sensor readings puts us with some crop available water and quite a bit at depth at 100 centimeters with 43%. So into this rainy period that we see again through here, so the mid-June, and this last rain increased the soil profile to the 50 centimeter depth. So what we're seeing, the green line represents the 10 meter sensor, the yellow line represents 20, black line represents 30 centimeters. 50 is blue, 70 is purple, and the teal is 100 centimeters. So with this last rain event here, you can see that it impacted to the 50 centimeter sensor depth. Middle of June, things are really starting to grow and quite quickly. And you can see after this rain, we start to watch that downward at 10, 20, and 30 centimeters. So giving us a pretty good indication that there is crop water use and a well-established root system of this wheat crop. Then we can watch 10 centimeters pull down really rapidly to about 15% soil moisture. So it's nearing its field capacity. And it's pulling to 10, 20, and 30 pretty rapidly. We start here about the 8th of July, starting to use it. And you can see the crop use some of the water, starting about that 3rd of August. So right in that dry period as that wheat crop's starting to fill, and it's pulling moisture from 70 centimeters. And then we stopped using water about the 20th, 22nd of August. Also, it's always kind of neat to watch these rain events, recharge the soil profile right in here, bumped up 10, 20, and 30 and a little bit to 50. And then right away after those roots start pulling and using that water really effectively again. I find it interesting to watch things as we go into fall. Some rains on the 19th, 20th of September, recharged the 10, 30 centimeters slightly. And we ended up the year, drier than what we started the year before. So that's some really good knowledge to take into next year's growing season in terms of where in the soil profile the water is and how much is there, and what that might mean for yield goals and fertilizer plans for the fall and the spring. That's where 2020 potentials come in. So we use that fall soil moisture number to get an idea of, based on what's in the ground and based on 30-year normals of winter precipitation and in-season growing season precipitation, what kind of yield goals might be appropriate or might be possible with the soil moisture in the field. So we started or ended the year with about 4.3 inches of soil water. Then it's interesting to look at the soil profile and get an idea, okay, there's 4 inches, but field capacity at 10, 20, and 30 centimeters. So most of that water is at depth. So at this point, we're relying on some fall or some winter recharge in order to know that the moisture at 70, 100 is going to be crop available next. So if we know that this 4.3 inches in the ground, we call that a relative certainty. It's not necessarily going anywhere over the winter. Things are going to freeze up. We generally end the year with more soil moisture than we start the spring with more soil moisture than we had in the fall, for the most part. So that's a relative certainty. Then we give the probabilities of whether or not you're going to get 50, 75, or 100% of the 30-year winter precipitation, as well as the 30-year in-season precipitation. And if we're relatively dry, 35 bushels of canola, near normal, 60 bushels of canola is possible. That's making effective use of the water and controlling all the other yield variables, the weeds, the disease, the insects, lodging, nutrient deficiencies, the whole gamut. 50% average are, kind of hard red spring wheat potentials, about 45 bushels up to 80 bushels if we get near normal precipitation. So that's kind of the crop intelligence data in a nutshell, showing you the crop intelligence and the water yield potential graph, the soil moisture graph, and our next year's potentials as they appear on the desktop. And all of this information is available on our app as well. It just, some of it looks a little bit different.
So in 2020, we have a few stations in canola and peas at the Egg in Motion plots. So there's kind of some neat stuff happening in the peas this year. So we've got it in check and in an advanced. I don't know the exact details of the advanced, but it's got a few more goodies to it than the check. And if we go in and look at these sites, right now we're sitting with lots of crop available water, so over 200 mils of water. We're a little later getting stations installed this year, but off the get-go, starting quite a bit wetter than 2019. 2019, these plots started with about 6.5 or 7 inches of crop available water. And this year we started the year with over 10. So that's in the profile to 100 centimeters and making some estimates about what is truly crop available at that point. Nice big rain on the 8th of July. A few little showers through the last week here. And today we're sitting yield positive with about 9 inches of water in the soil. So when you're looking at a soil moisture graph in season, it's really easy to look at the trends at the end of the year and see when the root activity started and stopped. And but as we're in the season, it can be a little more nuanced to figure out exactly where the rooting depths are. So we started full profile, really wet at depth on these sites. So 53% soil moisture, 50%, we're nearing saturation at those depths. So that's good to know there's lots of water down there, and it may ultimately have some implications to how much those roots explore those depths depending on what happens in the growing season. So right about here, we start to see some pretty good root activity at 10, 20, and 30 centimeters. Rain events will slow that root activity down again and then start easing. And you can see the very earliest signs that we've got root activity at 50 centimeters. So on the desktop of our of Crop Intelligence, you can look at the daily moisture change at each of the sensor depths. And this gives you a pretty good idea when you start to see daily moisture change consistent day over day, that's root activity. So if we look at 50 centimeters in particular, you can see those little tiny blue blips. And they're kind of inconsistent up and down here and there throughout the first part of the growing season. But then over the last 4 or 5 days here, we're starting to see a consistent day over day little bit of daily moisture change at each of those depths, or at 50 centimeters. So that's a pretty good clue that we're starting to get roots. You can see that same trend a little bit more emphasized in the 30 centimeter sensor. And again, same story with the 20. Starts a little earlier, but you see that consistency. It goes up when we get a rain and starts to go back down as those roots are actively using water at those depths. And our daily moisture change sum gives an idea of the overall change in the soil profile in a day. So the last couple of days, we're starting to see, 6 mils of daily moisture change on this pea crop, which is really nearing peak crop use on a pea crop kind of range. If we get up to 6, 7, 8 mils a day is generally the kinds of peaks that we see in a pea crop. So, without being at the site, I would venture a guess that we're moving into flowering, starting maybe the earliest of pod fill. So that's kind of exciting to see that. So 50 centimeters, we started to see that at about the 15th of July. 30 centimeters, starting to see some consistent root activity by about the 2nd of July on the advanced site. Now, if we go into the check, I expect things to be really similar in the check. The differences in root graphs, like the predictability, and it's really driven by soil moisture and those rain timings. We tend to see those factors have a much higher impact than the agronomy that we apply to the sites. But it's always interesting to just see if there's any differences. So similar patterns for sure. You know, we started to see some early use. The rains here recharge the profile, and then we really start using at 10, 20, maybe starting at the 30 at about the 5th of July. So, you know, a day behind at most, a couple of days. Similar story here with the 50 centimeter. We're really starting to see that trend show up at 50, you know, the earliest inklings of root use at 50 centimeters on about the 14th. And where are we at for daily moisture change? Similar story, maybe a little higher on this site at 7 mils a day. And again, those differences, you know, can be related to a slight shift in the probe placement in between the seed rows, slight differences in soil moisture at that sensor placement, but still interesting to watch these trends in the check versus the treat. So it'll be exciting to watch these sites move through the next couple of weeks and into harvest and see where things end up.
I'm Kendall G with Crop Intelligence, and this is Curtis Russell with Taurus Ag. Thank you for joining us and sticking it out to the end, talking about why soil moisture matters.
Thank you.